So there's the side view of our cylinder. And then we have a rope on it.
Mm-hmm.
And this rope is pulling, it's wrapped around the cylinder, and it's pulling on the cylinder that way. Okay.
Okay.
Cylinder itself weighs 50 kilograms.
All right.
It has a diameter of 0.12 meters, so from top to bottom. And then the force that they're pulling it with is 9 newtons.
9 newtons.
Okay. So, assuming the cable unwinds without stretching or slipping, what is the acceleration?
Let's see here. They give you mass, and they give you the force. Are you talking about angular acceleration or?
Let's find them both.
All right then. Let's see. The force is linear, so that relates to the linear acceleration. So finding that shouldn't be too hard.
Okay, but do we want to start out with a linear perspective in a rotational chapter?
No.
No,
You just thought
right?
about a rotational perspective.
Yeah, let's try the new stuff. Stray away from what we already know. So if we look at this, we have a rotating cylinder, right?
Okay.
So we can use one of the formulas we've learned. So let's see which one of the formulas would be best. We have torque is equal to a few things. We have what?
We have center of mass times angular acceleration.
You mean okay, inertia? Okay, that was another one.
Inertia.
Inertia about the center of mass times alpha. Good. What was the force one? What was the torque formula for force?
Torque formula for force.
Force.
Okay. Force times the radius?
The radius, okay, and it's actually radius first. And is it just a times?
No, it's cross multiply.
Cross product. These are vectors.
Cross product.
We're going to cross them, okay? So these are the two formulas we have to work with. So we can rewrite that formula if we wanted to as RF sine theta, because that's the alternative definition for a cross product, if you remember.
Mm-hmm.
And we have another way of looking at it. You might see it as the tangential force times the radius. And this is just pure multiplication on the last one. Okay, so going back to our problem, we have a cable being pulled. So my first piece of advice to you is to determine where the positive x-axis is and the y-axis, and let's draw a free body diagram. And then after that, let's work with our torque formulas. What do we know? Which one of these do you want to work with?
I prefer the inertia relative to the center of mass times acceleration.
Okay, so if I have torque is equal to ICM alpha, which one of these units am I looking for?
You're looking for the alpha because you have everything you need to find the center of mass.
Good.
Just
so
the inertia.
So let's figure out. Do you remember the formula for inertia of a cylinder?
It's 1/2 mass times radius squared.
Very good. All right. Most people don't have that memorized. Good job. And we're looking for alpha. What about torque? What are we going to do with torque?
Shouldn't we just make it equal to the 9 newtons?
Okay, would it be equal just to 9 newtons? Isn't that just a force? What else do we need? What else do we need for a torque? It's not just force; it's force times the radius, right?
Torque is force times the radius? Yes, of course it is. Yes.
So then here it would be force times the radius times sine of what angle?
Sine of 90?
90. Okay, so we would have RF sine of 90. So that sine of 90 goes to a 1, right?
Yep.
Okay. So you can start plugging in, or if you wanted, you could do a little canceling. You see how this cancels?
Mm-hmm.
And then we can multiply both sides by 2, and then divide by MR.
We just found the angular acceleration.
Good. So if you were to do that on your calculator, you should come up. So it'll be 2 times 9 newtons over the 50 kilograms.
Times the 0.06 meters.
Good, because they gave us the full radius. Diameter. We need to change it to a radius.
Mm-hmm.
And then that's going to equal to alpha, and that's going to give me a 6.0 radians per second squared.
All right.
Okay. Any questions on that?
No questions.
So now the question becomes, how do I go from alpha to
Linear.
linear acceleration? What was the link? Do you remember? It's the same way you would go from velocity to angular velocity. You multiply
by the radius.
There you go. Alpha times the radius equals acceleration. So 0.06 meters times this 6.0 radians per second. Now, in some situations, you just ignore the radian portion. This would be one of them, okay?
Mm-hmm.
So if there's no other units out there, you leave a radians, okay? But the moment you start dealing with meters and other distances, you just kind of neglect that. It's one of those weird measurements that comes and goes as it pleases.
Because it doesn't really have anything. It's just a constant.
Mm-hmm. So that would be your linear acceleration. Are there any questions over this one?
No, this is pretty straightforward.
Okay.